Ready for our dance-off?
It's a dance-off to save the universe.
What'd you say?
It's a dance-off to save the universe.
Mm-hmm. Yeah, that's what I was thinking of, actually, is that Marvel movie, whatever it was. The Guardians of the something or other.
Yeah.
Hello, Dr. Barth.
Hi, Eric. Welcome to Rubber Duck Engineering.
Yes, episode 41. We've done this so many times. We totally know what we're doing now.
Do enough times, we'll figure it out.
Cue the banner. That might have been the earliest cue of the banner yet. So hi. Last time we had sort of a fun little detour into Godot, the game engine, which was fun. I enjoyed playing with that. And
I really thought it was interesting how it had so many similarities with Unity, but was also different in other ways. So I don't know, it's sort of fun to compare them and like.
Yeah, I mean, I don't know any 3D game programming other than Unity, and that I only know from whatever 6 episodes we spent on it. So, but I was impressed at how far we were able to get in such a short period of time. But what we were brainstorming for tonight was to return to some Flutter fun, to maybe go back to our Pangram, although maybe take a little detour through a little project that I've been hacking on these last few weekends, which is a simulator for my kids' board game.
Which board game is that, Eric?
Well, I have it right here.
Dun, 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 dun. Cauldron Quest.
I don't know anything about whoever published this, and they have not. They don't know that I own this game. But anyways,
wait. Our podcast is not sponsored by the creators.
Our podcast is not sponsored by whoever the heck made this. Anyways, it's a game that's almost entirely random because it's designed for like 4-year-olds. But you roll a bunch of dice and you're trying to get the potions into the cauldron before the wizard blocks all the paths. And depending on so you roll the dice and either you get to move the potions, or the wizard moves, or then there's this magic. And when the wizard does magic, the wizard puts down blockers. And when you get to do magic, you get 3 choices. You can either reveal a potion, which you have to reveal all 3 potions that you want to get in the cauldron before they can go in, which turns out is really what the game is limited by. Or you can swap potion locations. Or you can do a super charm, which has a slightly lower percentage chance of going off. And then you get to move a potion up to 6 spaces, ignoring blockers.
Oh, so you can like hop over the blocks?
You can like hop over the blocks, or the wizard, because the wizard is also a blocker.
My kids do not know about the super charm. we played this game and we've never had a super charm.
Oh, really? Oh, well, so part of the reason why I do these, because this is probably my 3rd or 4th like game simulator that I've written. I don't know why I'm attracted to these. Some of it is that I finally learned the rules. I learned this last week because we've been learning at work about different learning styles. And I learned that I have a very, like a skim, that's not the right word, but like when I see a web page, I do not read it. I read like, a few words from every 3rd paragraph.
And you look at the pictures?
I look at the pictures, I look at the code, I just like, I'm very like, I pick out the interesting bits and then I go back when I need more. And I think I do the same thing with games. I have a lot of trouble like ingesting the 6-page manual, but when I actually sit down to program it, then I learn all the rules. But anyways, I sat down and I wrote, and this was originally only command line, and we could pull it up here. Well, we could pull it up, except I didn't set it up on this computer. So I guess I'm going to be doing that right now. I'm not prepared. Anyways, it was originally command line, and the purpose of it was to just tell me what the roll rates are. Like how often was I going to get a super charm?
Oh, just like Monte Carlo simulated out.
Exactly. And so I did that, and I made some progress. But as I said, I didn't do quite all of my homework, so we're going to get to watch me do it, I guess. We're going to pull up GitHub Desktop, and we want to move from Pangram to...
Can you embiggen your screen? It's a little bit difficult to read.
Oh, you're right. We got to embiggen. display settings.
Yeah, the skim learning style is something that I actually encountered when I used to write academic papers.
Oh,
And
really?
the advice I was given is, so the paper has a lot of text, right? But also has figures. And the advice I was given is that you should be able to look at each figure in the paper, read the captions, and then understand sort of the main or basic idea of the paper. And I don't think I like succeeded in this at all in any of my papers, but that was the advice I was given about how to help some people understand what was in the paper.
Well, it's amazing actually, because this was then reinforced for me shortly after when I watched my wife learn about Flutter. I was helping her install it on her machine and stuff, and her learning style, I learned through this, is totally different from mine. And so this theoretically should be it. Maybe it has to do a little bit of getting. If I can get up a terminal, who knows if terminals actually work on the Windows version of this, then it should work. I see, I gotta wait for Flutter to do it. But you were saying you learned about the skim learning style while reviewing academic papers.
Well, authoring that was advice I was given about how. I think the problem was I made some papers with some really bad figures, and my advisor was trying to gently encourage me to make the figures in my paper like make sense.
One of the things I learned in my work job is that I got to see, actually, I think for the second time, because I think I actually watched this talk before, a talk by some folks from gendermag.org, and their thing, it turns out, again, this is my skim learning style version of it, breaks down to like understanding learning styles, and their thesis is that part of the reason why your project in part has a gender bias to it, like you may have fewer women participants than half the population, as an example. It may be due to like the learning style that it biases towards. Anyways, that was learning about that in my day job.
That's really
it made me sensitive to learning styles, or more sensitive. Because
this whole show maybe probably appeals to some particular learning style that like jump in and let fail learning style, I guess.
I would not be surprised. All right, so Pub appears to be sad at the world. I apologize to the YouTubes that I did not set this up.
Oh, can we launch the Java missile? That was my favorite part of one of our early episodes. We did something, and we started downloading Java, and it was amazing.
What is it even doing? Why does it think Flutter Doctor? It's not Doctor. Flutter Doctor. Okay, Flutter version. We're learning all about how you can have your Flutter all set up wrong. This is all good. So let's try Dart, run, bin, simulate. I see. Dart, run, pub, get. This is our problem in life. Cloning into bare repository. Host key verification.
Oh, but is it a private repo? Maybe your GitHub credentials are not configured in a way that the command line can see.
Oh, that's exactly it. So the problem is that I used a get address, and I bet that sethlad. So sethlad dart a star. This thing. Probably just need to move to a HTTPS, and then the world will be happy again.
Oh, is this the A-star pathing algorithm?
Yeah, so this was another thing that I did as part of this, actually, was I updated the A-star pathing algorithm that I found for Dart to be null safe. Because part of the reason why I started this project was that I wanted to play around with null safety. and coding up the kids' board game was a way to do that. So I think if I just change
what I think is the neatest thing about GitHub is because it has sort of normalized the contribution flow. Like, assuming you sent a pull request to this repository.
I actually accidentally sent the pull request, but yes.
You accidentally, but but you knew how to do it. Like before GitHub, everyone's source control system was different, and you had to like learn how to configure your Mutt email client to normalize line endings in the right way to email your patch file to the mailing list or whatever. Like,
I remember Git being terrible when we first tried it, but GitHub actually made it viable because it turns out CVS and SVN were more terrible. I think they just needed like SVN hub, or I do think SVN didn't have the fork culture that GitHub does. Okay, so I believe we actually may have a viable thing now.
10,000 games.
Yeah. Oh yeah, that doesn't take any time. It takes 10 seconds.
Hold my orange juice. 10,000 games.
There you go. But that isn't the first thing I wrote. The first thing I wrote was this.
Wait, hold on. Can you tell us a little bit of what this output is here? Like what
I'm going to back up and bring it down. So this was the very first thing that I wrote, which was again to figure out. I think we click this. No.
Got to resimulate those 10,000 games.
Okay, so I just wanted to know, like this one I could understand. So the way these work is that you get to roll 3 dice, and for reveal and swap, I don't remember which is which, you need to get either all even or all odd. But you get then 2 additional reroll chances where you can reroll any number of dice. And so I think I had figured out on my own that it was about 1/6 chance or 2/3 chance. This one was more complicated, and I had to like write a strategy because this one you get the same dice pattern if you get 3 rolls, but you are attempting to get to the number 12.
Like they have to add up to 12.
They have to add up to 12. I'm not actually sure that my strategy is even correct here. I could show you what it is. If I go to roller, there's a lot of code here. We could spend a long time touring. But so this thing, try superpower charm, have a planner, because why not? But we plan a reroll where if the sum is less than 7, I reroll the 2 smallest. If the sum is less than 12, I reroll the smallest.
So how did you come up with this strategy here?
I think just by thinking. This is one of the earliest pieces of code I wrote, and I have not revisited yet. So maybe we should give a little more tour, and then we could talk about. So one of the next things that I wrote, was then starting to simulate. Okay, so what's the win rate of this thing? And the way that I approximated that was I simulated 10,000 games, and then I counted any game that had 30 moves. So you have to. There's 10 spaces between where the potions start and the cauldron. At least 30 moves and at least 3 reveals as a win or as a potential win.
Because if you could decide optimally which things to move, then you could possibly win there.
Yeah, if like luck went your way and you could decide optimally, and you that could possibly be a move. And it turns out that ends up being about an 80% win rate, 80% potential. Recently, only in the last week or so, I've added enough of the ability to the system so that it can plan moves. So it actually is executing a strategy, and that strategy currently wins 50% of the games.
I see. And have you been like improving the strategy and seeing that number go up?
Correct. Yeah. So when I first, made it go, it won 0% of the games, but then I got it to 20 or 25, and then I've been slowly working my way up to about 50%. I think it can probably go a little bit higher, but I don't know. But the game is not particularly complicated. Like all you're doing is you have very, very, very tiny amount of strategy, and all you're doing is basically racing what is the time that a 1/6 chance occurs 7 times to block all 6 paths to block all 6 paths, and then you get like a way to unblock one of the paths, versus the tiny amount of strategy put in to get again the 3 reveals and the 30 at least move units.
But there's something more subtle than that, right? Because as I recall, the wizard is like going around in a circle, and if the wizard like bumps into your potion, he messes you up or something, right?
Yep. Sends your potions back.
You have to like dodge the wizard, or does that not end up being a?
doesn't really end up being a factor as far as I can tell. Also, the paths only when the wizard, he or she, whatever it is, when it blocks one of the paths, it only makes your path 2 longer, which is just not that much longer.
So you can go around some other way to get around the block.
Yeah, you just go over to the next. So it might actually help, particularly the viewers at home who have never, don't have a 4-year-old and they never played this game. If we just run this, because in the last week or so, I've written a UI for this, so I could visualize. Because I kind of got as far as I could go tuning it from the command line is what I had decided. The command line and the debugger and unit tests, and decided I needed to visualize it. I haven't actually gotten the visualizer sophisticated enough that I've done any useful tuning from it, but it does exist.
So can you watch the planner that you built run through the game on the visualizer? Is that how?
I don't. I see. This is. I have.
There's an overflow.
It's an overflow. I think.
If you do like Command Shift minus, you should be able to.
Oh yeah.
There you go.
All right, so that's we could do.
Okay.
Anyways,
can you walk us through this visual here? Like what are we? This is a beautiful. I love the colors. What am I looking at here?
So the greens are the paths. Each one of these little sectors, I think they're called, or slices of a sector, or the like steps along the path. The outer purple ring is the wizard's path. That's the only place the wizard moves. These inner ones are where blockers can occur. And the teal in the middle is where you're trying to get your potions.
And the dark purple dot, that's the wizard.
That's the wizard, correct. And the wizard only moves one direction, moves clockwise. Okay. And so if you click this button, it doesn't move. Now, it's not quite sophisticated enough to show you all the possible moves, so sometimes you do it and it doesn't look like anything happened. Well, that's probably because a magic roll failed or something like that, right? I don't have quite all that code. So what happened was it revealed this one. And it will turn from green to white when they reveal. So
before we go on, I see some text above the circle?
This?
Yes.
So this is the board state. This is something that I built before I had a UI in order when I would be running the simulation, it would crash. And I would need to suck out the board state and throw it in a unit test. And so I built this whole harness. Like, I don't know what it is about this kind of thing, but it does it for me.
Well, it reminds me of what we do with the Game of Life, where we had a way of serializing and deserializing the state of the organism.
Mm-hmm. Yeah, so like right here. So it's very common. So you can see I didn't have it at the early days, but as I got more sophisticated, I'll make a planner, I'll make a board that loads from one of these strings. And the string, I can explain, it breaks down to, these are the required ingredients. It's slash delimited. So the first section is the required ingredients, which are just numbers in my system. This is the ingredient, whether it's revealed or not, and where it is. These are bottles. Mm-hmm. This big bulk of the slash. And then this is where the wizard is. No, this is what blockers are. The first path, the 1 index path, the 7 I'll have to check to see what that is. I think that's block. These are blockers. Sorry, that's the first index path 7th space is blocked because the 7th space is all the blockers. And this is where the wizard is. The wizard is on the wizard path 9th offset. And then this is whether or not the spell breaker, the remove one of the blockers, has been used. Mm-hmm. So, anyways, basically the idea is you can load this up and then you can.
It makes it really handy for everything. Yeah, I can tell this. Yeah, that's very useful for this kind of test because you initialize the board to the state, do the operation that had the bug, and then check that.
Well, when you and I used to work on the web, or when you and I worked on the bridge bidder thing, whatever it was, over a decade ago now, we built a similar sort of system, right, where you would want to load up an entire bridge hand, very quickly into memory. Anyway, so that's what this is. There's a little copy button that copies it into the baseboard. And then this is a scrubber.
Oh, so this thing already has the entire history of a game played out in it.
It doesn't actually. This
Oh,
is
it's just doing it live. It's doing it
it's
live.
doing it live.
That's so cool. Will it
It's
do the
kind of
same thing if you go back and forth, or will it
well
roll
because
different dice?
I control the random seed.
Oh, I see.
So I had to do a little bit of work, and I actually have some evidence to suggest that maybe I missed one, like I missed a shuffle somewhere, so there might still be randomness. That evidence is that sometimes this crashes. The slider will try to go either further, because the slider is set by play out the game to its finish, figure out what the furthest turn it was. And then it knows the seed, and so it's like, well, if you want me to be at turn 16, I'll just stick in that seed and run to turn 16. Here's the board.
I love it.
It's such a hack, but it works. So, because I mean, I think this is true of so much software, is that it's designed for some original purpose, and then it gets sort of twisted. Like, this was not designed to be visualized originally. It was designed to run as a simple simulation to like spit out a win rate.
And probably also to reproduce bugs, right? That's why you want to have a seed, so you could say, when the dice roll like this, the following thing happens.
Well, I started hitting all these bugs when I actually started trying to plan, right? So when I started actually needing to come up with moves to make, and then I wrote a separate system that verified whether those moves were legal, and the is this move legal assert was just firing like mad. And so I had to debug all of those boards.
So the planner would try to do something, and the rule checker would be like, no, that's not cool.
Yeah, if we look at, I actually sort of intentionally, so I didn't, oh, whoops, that's the Pangram. I didn't quite split, sort of everything got dumped into rules. This was the first file, but the planner itself is separate. It would be slightly better if the planner was async, one, and it would be slightly better if the planner was passed in an abstraction to work from, so the planner couldn't cheat.
So the planner could currently manipulate the board, change its state to whatever it desires.
The planner currently gets raw access to the like underlying data structures, which is wrong. And if you were to make a playable game over the network, yeah, I think back, I've done like 5, maybe 10 of these where I've like taken a game and I've like worked out the logic, in whatever language I happen to be playing with. Anyway, so this thing it plans moves, it plans charms, it plans that reroll like we looked at before. Anyways, when I finally wrote like this, not the pick bottle supercharge, I rewrote this so many times. What is it? Plan move? Yeah, plan bottle move. So originally it just planned one move. Now it currently sorts the bottles in the order that it would like them to move. Because too often you will find a bottle that's like right up next to a blocker, and the planner doesn't know how to plan a backwards move. The rules are actually pretty clear that when you roll a 3, you need to move 3. I violate that.
Well, can you get in situations where you're totally blocked in and you can't actually move?
There is 2 spaces between the wizard and the wizard and the. So basically, the short answer is mostly yes. Yes, you can get into. I think if I read the rules, the way I come to understand it is that you can move anything that's revealed into the cauldron, even if it's not needed. And you always have to move based on the number of the die, but you can move 1 forward and then 1 back, and then 1 forward and then 1 back.
I think so. If you're boxed in, you can bounce around in that.
You can just bounce back and forth. But you can get boxed into a 2-square area between the blocker and the wizard. So, and I haven't covered that. So that's like a crasher somewhere. Actually, no, it doesn't crash anymore because I have this explicit pass. Like if I ever get anywhere, I will explicitly set this flag and set the distance to 0. And then in my stats, which we could go back to now that we've seen enough of this. Like, I don't know if this is interesting to you. I don't know if this is interesting to our viewers, but
I find it fascinating.
So the simulate, which again got way more sophisticated over time, and as I said, it takes about 10 seconds to simulate all of these games. Because as you said, Monte Carlo. I think you introduced me to the concept of like a Monte Carlo simulation back Bridge, a decade ago. And it's super powerful to just try it all and collect the stats. Dart, there's some like nice package stats for Dart that'll do this kind of thing. You just hand it an array and it'll be like, oh, sure, the average and the min and the max. So like I also collect like magics failed. And like median is the interesting one here. So like median value is 10 magics are rolled, 5 of which are potion reveals, 0 of which are swaps. It does know how to plan swaps, but they're just super uncommon that you actually want to swap. Because you never want to swap unless it gets you at least 3 spaces closer. Because a super charm has an EV of 2.4.
Do you have to declare before you start rolling the dice what thing you're going for? Or can you look at the initial roll and then say, oh, actually, I see a lot of even numbers, so I'm going to go for the one that's all evens?
That is how my son and I used to play. But now that I've read the rules 5 times, I will tell you, you have to declare, and then you get your 3 chances.
I see. Okay.
So you rarely ever use the swap because it's just the EV isn't high enough. You have to have 2 things blocked in either direction, right? Because if only yours and 1, then the one next to you is blocked, you've only made the path 2 longer.
I mean, the time I've used the swap in playing the game is when, for some reason, I didn't have a lot of things revealed. And so I took an unrevealed potion pretty far along the track.
Yep.
And later was revealed to be wrong.
Yep.
And then I swapped in one from way somewhere else.
And the strategy that this will play when it's playing by itself in solo play which is the only way it knows how to play, right? It doesn't have a child that it's trying to coerce to a strategy. It tries really hard to reveal because reveal tends to be the blocking. And then
because you must reveal in order to win, like it's a required element to win.
And I don't know what I expect this actually tells us, but I suspect you have to, on general reveal, try to reveal 5 times before you get your 3 correct things revealed. Because even if you know that thing is the right ingredient, because all 5 others are revealed, you still have to reveal it before you can put it in the cauldron.
The cauldron doesn't know. You have to.
Yeah. Anyways, yeah. So like this was the bulk of it and how it was, but it was when I added this, and initially it was 0. That was a whole bunch of work, and I think you can drive that up higher, but I don't actually know.
Yeah, so I'm interested in the super charm planning algorithm. Like you said, you thought really hard and came up with that big if statement, and I'm sort of curious if there's a way of writing some algorithm or something to deduce this optimal reroll plan.
Yeah, I don't know that I thought really hard. As I said, this was one of the very first pieces of code that I ever wrote in this system, and I haven't touched it since. My guess is that this is mathematically computable. Like just, it's not even a guess. Like I'm certain that you could sit down and prove what the optimal strategy is here. I have not done that. It smells like a combinatorics problem from college.
Yeah, it also feels like something you could just brute force by running 10,000 simulations of like all the various possible thresholds and see how they do.
But yeah, I do not know that this reroll, but I actually suspect that makes a sizable effect on the game. Well, it could affect the win rate, definitely, because it certainly would. If you could increase the super charm rate, you just completely remove swap, because why? You don't need to ever swap around a barrier when you just blast right through them, right? Mm-hmm. If you had 100% rate of super charming whenever you got a magic, you would just use it.
I mean, you can estimate that by just commenting out most of this function and always say reroll none, running your 10,000 games and see what happens to your win rate.
Sure. Where'd it go? So what is the hypothesis here?
I was just looking at what effect this is going to have on the win rate. If it has a small effect, then that means it doesn't matter too much. what strategy to use for planning the super rolls. But if it has a big effect, then this seems like an important function to think about more carefully. It's somehow it's mad at you.
I don't quite understand why. Rules, control click, fold. Oh, I see. I commented out a little bit too much. We want the, if there's any nulls, let it roll the first time.
That seems like an important aspect.
Yeah, I wrote one of these for League of Legends. I wrote one of these for Bridge. I wrote some of this for Innovation some many years ago. And I find like I learn things about the game by letting the computer explore the strategy space for me. So this looks like our win rate went up.
So, okay, so we repeat that, like comment it back in and compare. So 50.8%, if I'm reading that correctly.
I don't know that I have any explanation for that.
I mean, this is sort of the way I like to explore systems like this, is to do these kind of sanity check changes and like compare my mental model of how the system is working to what's actually working.
Our max wins went down, but that I don't understand why that moves around. Yeah.
So is that a significant change, like 50.8 to 49.9?
It's on the border. Like I've definitely done changes that have been 1% changes. I don't know that it's statistically significant because removing some of these rerolls is going to change the randomness, right? When we remove that, we make fewer calls to random.
Mm-hmm. So when you run the simulation, are you always using the same seed each time?
I believe that's how I currently have it. It didn't used to do that, but it does these days. The way that it currently does it oh no, it does not. So it's creating a new independent random every time. It is not sharing a random between. So it's just creating a new random object, which maybe shares seed. I don't know. I could make this, like, I can pass a seed to this and it'll do that. So like it would be very straightforward to have static int seed equals 0. Seed. I will now make them all. I don't want to do static there.
I think you started writing C for a second there.
Too many years. Too many years.
So now you're going to run the same. Every time you invoke this command, you're going to be looking at the same 10,000 games.
Yes, as much as. So that's 50.8.
Well, now it should be exactly the same, right? Because you're getting the same.
There should be 0 variance.
And if you change the seed to 30,000, we should be looking at another set of 10,000 different games.
Then we think that these numbers should change, right? Based on some amount of small variance. Yeah.
Yeah. Okay. So that sounds like the 50.0 that we saw before is not outside the realm of variance for the actual wins.
But that would suggest that the super charm strategy has so little effect because the median is that we do one of them. So at best, it's like it moved you 6 spaces.
Yeah.
or rather, with median 1, that means the EV is that it moved to 2.4 spaces. Whoop-de-doo.
Mm-hmm. Which is not significant in the course of the game.
Is less than the smallest. Well, let's if you look at potion. Potions moved rolled. This is the times we got to roll. And then potion spaces moved. Median is 38.
Mm-hmm.
So it's not nothing. And moves lost is all the times that I am either cheating by allowing it to not move the full distance because I'm, say, moving up to a blocker and then stopping. Or it may also include moves lost when moved into the cauldron. I don't know whether I included that or not, because that's the one time you're actually allowed to not move the full distance.
I see. So do you have a sense for like what part of the planning is most would have the most effect on the actual win rate? Sorry, I'm now thinking of this as like an optimization problem. Like if my job were to optimize the system, how would I think about doing it?
I don't know, and I haven't spent enough time because I've been building the UI with my most recent commits. But my sense is that we may be nearly optimum already. Like it's possible that 50, maybe 55 or something like that. That's like the max win rate. But my sense is that it all comes down to reveals. So it's like, how often do you actually get the dice to come up with a magic? And then also then the 2/3 chance that you get a reveal. You succeed in your reveal.
Oh, for the max wins, you're just saying if you get 3 reveals at all, then that's counted as a possible win.
Correct.
But that's really optimistic, right? Because it's not really under your control which one you reveal.
Correct.
I see.
Yeah, I mean, the max wins is very possibly just flat out wrong. Like, again, this goes back to like, this was the first thing that I added here in a sense of what is the cheapest way to evaluate the possible win rate of this system.
Yeah, just thinking I think it's an important thing when you're optimizing a system to have some, like sometimes I call it the speed of light. Like what is the fastest it could possibly be, so that you know like how much is left to try to how much water is left in the well, or like how much headroom you have, whatever your favorite.
It's somewhere less than this, right? There's no way it's 80%, because we know already that like if you only revealed 3 things, those are not going to be the 3 every time, certainly, right? I actually don't know what the answer to that combination is off the top of my head. But I suspect there's maybe 5% left in this.
Mm-hmm.
And it probably all comes down to bottle planning.
Because if you ever move a bottle that you were not you didn't actually need to get to the cauldron, then that was a wasted move.
Well, you can't know that. But for example, right now, one of the choices that it makes is based on the principle of least regret. When it doesn't know which bottle to move, it will move the furthest away bottle.
Mm.
Like, say all the bottles are unrevealed, it'll move the furthest away bottle.
I see. That's sort of the opposite of the strategy that we use when we play it in person. We try to get them as close as possible, and if we got it wrong, then we try to do the swap.
Correct. And so it's very possible that strategy, the different strategy of focus on getting one as close, or like another way that I now realize in retrospect, but again, I'd spent my brain budget on the planning problem and I hadn't gotten back to it. This bottles in preferred order. Remember, I used to just pick a single bottle, then I moved to this list of bottles. But I've realized since then that you actually want to make a full list of plans. Because making a full list of plans would let you choose between, it would let you account for those wasted moves, for example.
So what do you mean by a full list of plans?
So you'd make a plan, or possibly multiple plans, but probably a plan for each bottle. And then you would look at that full list and sort that by which of those 6 possible boards is best.
I
as
see.
opposed to right now where it just gives you six bottles from this, and then the actual planning algorithm has this 2-pass thing where it first tries through the sorted bottles. It tries to find the shortest path to the cauldron, respecting blockers. And then if you're just completely trapped and you can't even get to the cauldron, you're null. Otherwise, it tries to make a plan from that path. It checks to make sure that that's legal, and then returns that. Otherwise, if that failed, if we failed to find like a legal path this way, then now we try and find the shortest path, ignoring blockers.
Do you have a way of scoring boards to say, I would rather be in this board than in that board?
Nope.
Okay. Because the way in general I think about these sort of game planning problems is there's two pieces of them. One is the looking at a given board state, trying to say, okay, what is a good move for me to make just by thinking it through, which I think is referred to as the policy problem. And there's also the, I forget what they call the other one, the evaluation problem, where you look at a board and say, would I prefer to be in this board or that board? And then you can build these planning algorithms in two different ways. You can build them with very, very little policy, where they just try every possible thing, and then they sort of simulate forward and then evaluate, do I like the state that I got to after doing this for a while? Or it seems like what you've done here is the opposite of that. We've put a lot into policy about thinking about what would be a good move to make, but not very much into like simulating the game out for a little while and then checking, did I like where I got?
I agree. Yeah, like the planner has no ability to look ahead. It's just making, or no ability to simulate ahead, which would be a very reasonable thing for it to do.
Yeah, I read about a little bit this about the some years ago when the AlphaGo came out, and it was challenging some fancy Go player or something, and they were explaining how AlphaGo worked internally, and basically it had two neural networks, the policy network and the evaluation network, and they just basically trained those two networks to either like evaluate what the board state was or like plan what a good move was, and then all they did was just a very simple search based using those two networks.
This is a repeated failing for me in these planning systems that I build, because I do tend very heavily towards the how do I build the most rigid system that most perfectly articulates the game, and then plan based on that, somewhat as a human would at some level, instead of using a neural network or even Monte Carlo to its like a fuller extent, and a dumber algorithm. I always sort of bias in that one direction. But something to explore. I think we ended up spending most of the episode looking at this. So
I thought this was really interesting. So other times in the show, we sort of worked on very small pieces of code and sort of built them up over time. But it's sort of interesting to take a tour of this larger project that you've built and sort of see structurally how it fits together. I feel like we just produce different kinds of code when we're live typing it on the air.
Oh, totally.
You clearly put a lot of time and thought into this and designed it and built it.
Let me see if there was anything else interesting. So I had to use the A star. This was a big frustration. So I wrote my own sort of Dijkstra's with this. So if we go to board.
Can you back up just a minute? So either A star or Dijkstra, how does that fit into what we've seen so far?
Well, so you often want to know what is the distance between you want to know. So I went through multiple board representations. Initially, it was just a couple lists and indices. Now it's actually a connected graph. And then very recently, because of the UI stuff, it is now a connected graph that actually has polar coordinates in it. So with the polar coordinates, I actually, and they're segments. So it's not pi or anything like that. It's like you're in the 0 segment, which is like a whole section of the circle.
So like when the wizard blocks something, that changes the connectedness of the graph?
Currently. But another innovation that I realized in my third attempt through path finding. So you have to path find, right? So how can I get to the goal? What is it going to cost me? Right. And currently the way that I do that is I do change the connectivity of the graph. And I actually think if I did it again, I wouldn't change the connectivity of the graph. I would just change the weights of the graph.
So like this takes an infinite distance to travel or something.
An infinite, or even just 100, right? Like it's never a reasonable path. What'd you say?
So far that you couldn't possibly do it.
Correct. And I think if I went back and refactored that code, that's what I would do. So initially I wrote my own sort of like pseudo Dijkstra's using something that I thought was kind of clever at the time, in that I have versioned storage, because any of these Dijkstra's or any of these dynamic programming algorithms, they have to like have some side storage for like what is the cost to get to this node. So you can then tell your neighbor, oh, by the way, you're one more than the cost to get to this node, or you're n more, whatever the like edge weight is. And I came up with this cutesy little thing, a version minimum distance. It's basically just a versioned. It's just a versioned int.
What is the version?
What'd you say?
I was asking what the version does for you.
It allows you to, every time you path plan, or every time you change the board, you just increment the board's version, and then you've immediately effectively invalidated your cache. Because I didn't have a good way, at least not a normal is the wrong word, but I didn't have a standard data structure. I could have used a map maybe. I could have listed all of the edges of the graph in just an array, because sometimes that's another storage technique for graphs. You just have, here's the list of edges, here's the list of nodes. But instead I have this space thing, which space is just a node in the, Knuth. I used to have, one of the Knuth books or whatever in college, but it's just like a node in a connected graph. And all it does is it knows, you can ignore this. This was later added. It just, where is it? Here we go. I don't know why I stored these way down here, but it just knows it's adjacent spaces.
That's a very sparse representation of the connectivity graph.
And so initially I built up this sort of like pseudo Dijkstra's. I'm only saying pseudo because I actually don't know if I correctly followed Dijkstra's, because again, with being a
you skimmed Dijkstra's algorithm.
I skimmed enough, I typed some code, and the compiler seemed to like it enough. But it actually
passed the tests, so it must be cool.
Oh well, this came back to bite me, because it appears that sometimes, and I've been slowly moving away from my code, because sometimes the A* that I'm using from Seth Ladd, that I moved to null safety and hopefully didn't break in the process, the A* from there and the pseudo Dijkstra's thing don't always seem to agree. And I haven't gone to track down all the times when it does. So there may be a few percentage win rate too. But anyways, I needed to know the distance to goal and the unblocked distance to goal. But really, I should just delete these and just use A* everywhere. And the A* node, initially, I used it the way that the docs say to use it, as a mix-in. But there again, you get into a versioning problem. And because I'm constantly changing the connectivity, that mix-in doesn't know when to clear itself. And so you'd run the search, and then you'd now run the search with the unblocked, so you could walk through blockers, and it'd be like, blah, and blow up. So anyways, I could make that all that better. This is also just sort of the organic nature of software, that it sort of, it grows in weird ways.
It's like tree rings. Like at some point you put this thing in, and then your tree grows around it, and then it's just like part of your tree. It's like,
yeah. But all this code should go. All of this should go. It was cute. I'm glad I wrote it. But yeah, and this is the complicated keeping up these distances, because you have to know, am I allowed to update from this neighbor? Okay, can I trust this neighbor's version? This is the are the versions the same? Because if the versions aren't the same between the distance to goal and the unblocked distance to goal, it means I traverse through that neighbor, because it's a blocker, right? For the but I didn't traverse yet, so I've only updated one of the versions. So again, there's something.
It looks a little fragile. Like it seems like you could easily forget to write the
Correct.
statement that you highlighted.
Anyway, so I think maybe this is the thing I'll next hack on is I need to delete all that code basically. Another thing I've learned in software is that you really want to always have one source of truth. Anytime you are caching data, the caches, keeping those caches versioned and correct is hard.
There's a famous aphorism about this, right? The two hardest problems in computer science are naming, cache invalidation, and off by one errors.
Yes. I think off by one errors we've gotten better at over the years as computer scientists.
Yeah, well, once we all agree that indices started at 0,
yes,
that Pascal was crazy, then it's gotten a lot better.
And we got null safety. Null safety, I think, helped a lot. None of the languages do static checking of array lengths, which I think in some cases they could. But off by one is still a problem here and there. It's even a problem here in this thing. But it was like with these chords. So these chords, this is the polar coordinate thing that I invented. And the reason why I had to do that was in order to draw this. This was way easier to draw if I had some way to index. If I had some way to...
Is it like a giant custom paint?
Yeah. And it really, so it's actually 2 giant custom paints layered on top of each other because the back one never changes. But it has to, where is it? This is all in main. It's amazing how little code, like there you go. There's the 400 lines of Flutter.
To do this whole UI.
To do this whole thing. Which,
that's cool.
Isn't that crazy? But like, I tell you, half of that code is probably the me futzing with text. But this thing.
Oh, that just draws the board just like straight out.
Yep, just straight up. I was like, no, I'm not gonna make an SVG or whatever. I'm just gonna draw it with custom paint. So I draw the path backgrounds, and then I draw circular separators, and then I draw voids. And then I draw the wizard ring, but because I don't have the ability to do a cut sector, so like here, if I turn this off.
Oh, you only fill circles?
Yeah. I don't know how to do a cut.
So you're over painting every one of these. Oh my gosh.
Not everyone. I have to overpaint critically for the wizard circle. Oh yeah, and I don't think I've currently marked it as.
Sorry, we should define the term overpaint. Imagine you were smart and you were trying to compute all the pixels that were going to be on the screen. If you were infinitely smart, you would only have to paint each pixel once, whatever the final color was going to be that was on the screen. So the overpaint count is for each pixel. How many times did you fill in the color of that pixel before you figured out which one was the last one? And so what he was showing there with the full purple is that he painted purple all the way on the inside, and then he was going to overpaint it again with something else.
Correct. And you can tell me, like maybe with a clip, maybe with a circular clip, I could have.
Well, the clip's not really going to do anything different than what you've done. It's just going to draw the circle to an off-screen buffer and then copy it back and mask it off. Like non-rectangular clips are not really any more efficient than what you're doing here.
So I think the real answer to this is this is also I'm not actually sure I used stack correctly here.
You could do a path, right? If you did a path that was the.
Oh, I could. Yeah, I could do a path and fill it.
I mean, you're turning out different things, right? Because the shader for drawing a circle is very simple. The shader for drawing a non-convex path is like, I don't know. Ski is brilliant. It knows how to do that stuff. But
I think the simple solution though is I just wrap this thing with a paint boundary.
custom paint does that for you.
Oh,
Yeah, custom paint has a built-in repaint boundary. So once you've drawn this thing, it's recorded for you.
Yeah, so I don't.
As long as you have your should repaint, as long as your should repaint function is doing the correct thing.
Well, so remember, I divided them into two, and the board painter never.
It's like I don't need to repaint. I always paint the same thing.
Correct.
Yeah.
Right. That was why I intentionally divided them into two, and then the pieces painter, which takes a board, and it's a much simpler thing. All it does is it collects up the few spaces that could have pieces. Or sorry, it collects all the pieces up, asks those pieces what their spaces were, and then walks those spaces, painting them. And I did some more cutesy stuff here, like the paint tokens. I use my fancy polar, like pseudo polar. I mean, it's polar. It's just in a different
different units or whatever.
There's like a constant multiplier, right? So I take my polar coordinates, which was made this so much easier. And then I take my fake polar angle, I chose the segment, and then this is how I turn it into real polar coordinates. And then I take this, I don't know why I call it offset from polar, but really this is taking polar and moving it back into Cartesian.
Mm-hmm.
I feel redeemed in some ways by episodes like this, by the way, because it's still somewhere in my brain, I like self-identify as someone who writes code occasionally, and yet I don't write a lot of code in my day job. I have other things that I do for the team, and I don't feel like I write a lot of code on the shows, but here I have done my part.
Well, I think part of what we learned from doing the show is that your work style is very focus oriented. And so the ability to like sit down and focus and write this is really beneficial for you.
Yeah, I love just going off into the zone. Yeah. It's a different life that I currently lead.
Well, Eric, thank you for sharing this project. I find it fascinating to see how it's put together and how the different pieces work. And
yeah, I think it was fun. It was fun to write. I don't know how much more, if any, I will do for it, but I think there's definitely more that could be done. Will this change the way that you now play Cauldron Quest next time you play with your kid?
Yeah, like according to what I've learned now, we're using very like incorrect strategies. And
well, I do think that your point of the minimizing regret basis that I left for may be wrong, of equally distributing all moves across unknown tokens, as opposed to trying to go hard and then betting on being able to swap.
Well, I'll horrify you for a second. We never move backwards, or we never move around the wizard ring.
Oh, because that's not allowed, or?
I mean, I don't know. Like we for a while we didn't even know that was allowed. Like that was the wizard's ring. We couldn't go there.
I sympathize with you because my child also taught me this game the first few times we played. It wasn't until I spent a lot of time reading these 2 pages of
the specifications on my site.
I built a board that actually looks kind of like the original board, just turned a little bit. Anyways, the code's up on GitHub. I don't have a here. I could Cauldron Quest.
Oh, you're making a banner like live right now?
Oh, live.
What?
Right. I too can type characters. So if you wish to see the terrible code that I wrote.
No. That code is beautiful, Eric. Please don't start your bullshit.
Anyways, as always, it's fantastic to see you, Dr. Barth. I guess next week we'll go back to Pangrams, or who knows where we'll go.
Sounds like fun. See you next week.
So take care.
See you.